our team Central Park. Michelle is our instructor, and we are Grace, Jason, me, Prashant, and Duong. And we made a digit classifier, a model that can identify and classify digits.
So one reason why we built this model is because this AI can be useful for people in many different ways. We also made this model for math teachers so that they won't misread students' work. So one day in the middle of AI camp, I was reminiscing about my misgraded math test from first grade. And my teacher had unlawfully misinterpreted my 11 to be a 77. And I decided to help teachers so that no other students will suffer the same trauma ever again. This AI project idea has many different options to choose from, such as digit identifier, letter identifier, or even word identifier, and can be expanded on. We also made this model because we wanted to help expedite the process of turning handwriting into computer readable data.
Things you can use this for is that teachers grade fairly, can detect license plates on stolen runway cars. You can help the process of auto grading, bank check processing, and form data entry.
Collecting data. We used a database from MNIST called MNIST for our data. MNIST is made up of over 3,000 images. The images had very specific, were very specifically formatted. They were 28 by 28. They were a black background with a white digit. And we use label box to label our data. And we split the data into categories from 0 to 9 and drew a bounding box around it. While training our data, we did remove some files out of the final training set that we believed would affect the accuracy of a model. For example, like an 8 without a bottom loop, because that would confuse the model since it's meant to recognize patterns. If it sees an 8 that doesn't like match any other 8s, then it would confuse it and like mess up the model.
So to train our model, we use something called YELLOW, and YELLOW is an object detection repository which can be trained to identify different things in an image. And so we incorporated YELLOW into our model so that we can train it to be able to identify different digits. For training, we used 80% of our images to train, 10% of them to test, and the last 10 for validation. But before we trained, we also created text files so that we could store our labels and bounding boxes so that YELLOW can use them to train. And finally, during training, we have to calculate loss, which is basically how bad our model is. And so if our loss is really high, that means our model is very bad. And so we calculated loss in the form of IOU, or intersection over union. And so what that is when we're predicting, our model will draw a box around where it thinks the digit is. And IOU is basically how much of that box overlaps with the bounding box that we drew for that image. And then to evaluate our model, we used a confusion matrix, which is on the right, and the labels on the bottom represent what the model predicted, and the labels on the left represent what the image actually was. And so the diagonal boxes are accuracy, which is pretty high, but however, this accuracy might be affected since the data we use to create this confusion matrix is very similar to the data that we use to train our model. But some other factors that contributed to our accuracy are that we labeled over 3,000 images and we used a well-maintained data set, which means all the data from there is very good to use. And then we also let the model train for an appropriate amount of time.
All right, so we encountered many difficulties when developing this model. First difficulty was that the training time estimate given by YOLO, it wasn't exactly accurate. It took more time than previously estimated, which messed up our schedule by around half a day. Another major difficulty was that the entire MNIST dataset was homogeneous, meaning they all had a black background, white digit, and were all 28 by 28 pixel images. So since the data wasn't diverse, if you were to put an image of a black digit on a white background, the model would get confused and potentially misclassify number. One last problem that we had was the website platform that we used, NicePage, was very finicky. So sometimes whole text boxes or images would just disappear and we would have to redo them or remake them. It was also hard for us to decide on certain aspects of the website, such as like the color or the design. So we learned many lessons throughout this journey. Our first one was that in AI, the data's quality and quantity is more important than the coding itself. If there isn't enough data or the data isn't good, the model won't train properly. Another lesson we learned was that the data has to be diverse, which means the data can't be homogeneous, like the data set that we had. It has to have pictures of different backgrounds or maybe different colors and different properties. One last lesson we learned is the model, it won't be perfect the first time we train it. Oftentimes you have to redevelop the model multiple times until it is near perfect. And obviously AI is very cool.
Thanks for listening. And now Preyansh will show you our website.
All right, so this is a website we made using NicePage. So here we just have our project overview that just tells you like what our model does. Here we have directions on how to get the best results out of the model. So you should have a medium-sized square image and a black background with a white digit as shown in the picture on the left. And the file type should be JPG, JPEG, or a PNG file. And the digit should have one or maybe two digits in the photo. And then we have applications as listed in the slideshow, then our motivation right here. This is just about the team, Michelle, who's obviously our leader. And then we have Hartigan, Jason, Duong, me, and then Grace. The resources that we used, first we used MNIST. MNIST, it gave us a data set of around 3,300 photos, and it's kind of hard to find such a large data set on the internet. Then we used the label box. We labeled all of the images. And then we had YOLO, which is an object detection repository, and it used the images that we gave it to train itself. And then obviously AI Camp, which is a great environment. I really loved it, and so did we all. And all these icons just lead to their respective websites. So there's a bit about YOLO. This is label box, what we used to label it. And then MNIST, it doesn't have an official website, but this is like the website that we found for MNIST. And to show you the model in action, these images were created by Jason. He used Krita, which is a drawing software, and he could get black background in white images. So here you can see it found two with 100% confidence, and it drew the bounding box around the two. And I would say it's fairly accurate. Just for a few more examples, you just click try again and start classifying. Here it found a 3 with 88% confidence, and obviously the bounding box. And then here it found a 1, 83% confidence. Then here it's a 7 with 77% confidence. And now, so this image that I'm getting right now, we got it off of Google. And as you can see, it says that it found a 6 with 69% confidence. And this purple right here is like the bounding box that it attempted to draw. So then down here we have, why do we miss sometimes? So one reason our model might miss sometimes is the data that it was trained with was like specific to the data set. So the image that we gave it, white background and black digit, it doesn't satisfy the recommendation that we have on the website, which is a black background, white digit, and then a medium-sized picture. So that's why the model misses sometimes. And on the right, we just have another confusion matrix, which further shows the model's performance. And thank you for listening. That's our website.
That's awesome. Great job, guys.
That what's crazy about this is I literally did a project using the MNIST data set in my junior year of college. Like literally.
MNIST is actually pretty famous. Does anyone know what MNIST stands for? It is the, let's see if I can get this right, Modified National Institute for Standards and Technology. And it's basically like, remember how in Python we had Hello World the very first time? It's basically like the Hello World of data sets. It's always a black background with a white number drawn on top of it. Does anyone have any ideas on how we could fix that problem?
Maybe taking some of the images and then inverting the colors so that way it's white background, black image.
Yeah, good idea. That's what I was thinking too. All right. Thank you guys so much. That was really cool.
Alternatively, you can take any new input and then convert it to black to white on black.
Yeah. So we only have 2 left. So next up we have Oxford, and then we're going to go to Lexington, but Oxford is first.
All right, I will share my screen. And Shreya, you want to take it away?
Yes, thank you. Hi, everyone. On behalf of the Oxford team, I introduce to you our project, the Tweet Mimic. This is a project that uses NLP, natural language processing, and AI to imitate tweets based on the user's prompt and the computer's analysis of the chosen Twitter account. Using NLP, we were able to analyze several large Twitter data sets to recognize the patterns. Our generator can then create tweets imitating the patterns that it has found in the world's biggest Twitter influences. Now I'll hand it over to Kosi to introduce the Oxford team.